All right, we're going to work on problem 28-4. That's number 4 on page 28 in your workbook. You do not need to replicate this in your notebook. The outcome of this will be a formula that we use. That needs to go in your notebook on the page with important formulas. But this you can work directly in your workbook. Fill in the blanks in your workbook as we do it here. So number 4 on page 28, the goal here is for us to understand if we have a polygon with, you can have any number of sides on a polygon, right? Polygon means many sides here. And we're going to figure out then, given the number of sides of this figure, can we determine what are the number of degrees inside the polygon? Now the simplest of polygons is the triangle. And for a triangle, we know how many degrees are on the inside of a triangle. We say it all the time, and at one point we even proved it, right? We proved that the number of degrees on the inside of a triangle, the sum of the interior angles, is 180 degrees. Now, we know that, we've proven it, it's a fact. What we're going to talk about here, when we say polygon, are regular polygons. And regular polygons are polygons that have sides that are congruent and angles that are congruent. And so we're gonna go ahead and mark this with some congruent sides there. That's an equilateral triangle. We know that all triangles have angles that add up to 180 degrees. If this triangle is equilateral, then we know the number of degrees in one angle, we've got 3 sides, we've got 180 degrees, then we know that this is a 60-degree angle individually. Now, how many non-overlapping triangles are in here? Well, it is a triangle. There's only one. And why is this important? Well, if we have a figure made up of triangles and we know each triangle is 180 degrees, then we can just add up the number of triangles, add up the number of 180s, and that gives us the total number of degrees. So let's talk about the next simplest polygon we know. The next simplest polygon we know would be a 4-sided figure. What do we call a regular 4-sided figure? Regular. All the same lengths, all the same angles. 4-sided, quadrilateral. It's a square, yeah. It's a square. It's got 4 sides. And if I draw lines coming from one vertex, how many triangles, non-overlapping triangles, do I create? Well, I create 2. And so how many total degrees do I have? The sum of the interior angles, 360. Now I know that because I know in a square, I have 4 angles and each one of those angles is 90 degrees. And 4 times 90 is 360, right? 360 divided by 4 is 90. Okay, so far so good, yeah? How about the next one? Again, we're talking about regular polygons. So all the sides here are congruent. 5 sides, that's called a pentagon. How many non-overlapping triangles? Well, see if I can draw these in here. Come from the same vertex. I've got 1, 2, 3. I got 3. So if I have 3 triangles, how many total degrees do I have? The sum of the interior angles. Well, what is the sum of 3 triangles? 3 times 180. 540, I think. 540 degrees. 540. So then how many degrees do I have in one of these? angles. It's regular. So all 5 are the same. If all 5 are the same and they total 540, yeah, divide it out. 108. Each one is 108. All right. Next up, I do not draw this one well, I will admit. But here is our 6-sided figure. 6 sides, that's a hexagon. I'm going to draw in my non-overlapping triangles. See how many do we have here? 1, 2, 3, 4. What is the sum of our interior angles? 4 times 180. 720. I'm dividing that by how many angles? 6. It's 120. All right. Now there's a pattern happening here. Obviously, as we increase the number of sides, then all of these other numbers are increasing. But by how much? Let's say I have a 70-sided figure. What? 70? 100? 150? I can't draw that. But can I put together a formula? What if I have an n-gon? An n-gon. What? N-gon. An n-gon just means, I don't know how many sides it has. Let's just say we don't know. If I have an n-gon, how many triangles would it have? Well, what's our pattern here? If I had a triangle, it was 1 triangle. If I had a square, it was 2. If I have a pentagon, it was 3. What's our pattern here? 4 was 2, 5 was 3, 6 was 4. What's our pattern? 3 minus 4 was minus 5 minus 2 was 3. 6 minus 2. This would have to be whatever n is, I'm going to subtract 2. I'm going to subtract 2, right? 6 minus 2 would be 4, 5 minus 2 would be 3, 4 minus 2 would be 2, 3 minus 2 would be 1. Whatever the number of sides is, if I subtract 2 away, that's the number of non-overlapping triangles. And then I know the sum of the interior angles, I just take n minus 2 and multiply that by 180, right? However many triangles, I multiply that by 180. That tells me the sum of the interior angles. And if I want to know the number of degrees in just one angle, I'm going to take that big number, n minus 2 times 180, and I'm going to divide it by the number of sides, right? If it's a regular polygon, a regular n-gon, then I'm going to divide by n. That tells me how many degrees in just one angle. All right? This is problem 28.4. If you look at the next problem, number 5, we've already completed that one. And angle A, I had to give to you. I told you angle A when we worked that problem because we hadn't done this problem yet. But now if you look at that, take a look at angle A. It tells you that the pentagon is a regular pentagon. You can now work out what angle A would be. A regular pentagon has 5 sides, so it has 3 non-overlapping triangles. So we take 3 times 180 and divide it by 5, and one angle would be 108. You need these 2 formulas in your book. If the problem asks for the sum of the angles interior angles of a polygon, any polygon. You need that one. If it asks for the number of degrees in one angle of a regular polygon, then it's this one, divide by n. Make sure both of those are in your notebook.